start this. Okay, all good? How was the food? You like it? Yeah. Good, good. Before starting, how many of you are new here attending this as a first time? Raise your hands. Oh, almost 30–40%. Sounds good, sounds good. Okay, then let me first introduce myself. I'm Alok Adhav, and welcome back to K8SUG Meetup. This is a 33rd meetup that we are doing it here in Singapore. We are a very big community. We almost in the meetup, we have like more than 20,000 members, LinkedIn, 10,000 followers and 13,000 in the LinkedIn group. And we are growing every day. So keep supporting us. We are passionate about Kubernetes technology, and that's why we are here, right? Everyone here wants to work somewhere close or nearby to Kubernetes, and that's what our mission is, to accelerate Kubernetes adoption. And we are learning from each other by sharing Kubernetes skills. We have a global footprint. We are not only in Singapore, we are also in Australia, Canada, UK. In Australia, it's Melbourne and Sydney. In Philippines, and soon we'll be starting in India and Sri Lanka as well. Okay, so you'll find meetups in these countries as well. These are the today's speaker. Okay, first is by Leroy Lim. Look into simplified EKS permission management, IAM access, entries, and EKS pod identities. This is from Amazon Web Services. Second is Mun Kiat, after you deploy AI Kubernetes. This is from TYK. And third one is Unleash the Power of Within, SPH Media Journey to CI/CD Mastery of Self-Hosted Runner with Karpenter. This is from SPH Media by Abhishek Srivastava. Okay, so these are our 3 topics and 3 speakers that we'll be doing. The main sponsors of K8SUG is Code Cloud and AWS. Thank you so much, AWS, for providing this location and definitely the food. And this particular event sponsor is AWS and TYK. Meet our team. These are the organizers, the main founder, Yongkang, Fazir, and Ritesh. Our team is definitely growing right now, and we have more members in our team: Ramalingam, Shiva, Fatima, Jignesh, and me, Alok. We have multiple next meetups in different countries. These are the upcoming events, particularly for Singapore. We have 12th November next meetup. So most of you guys, if you can make it, definitely see you on 12th November for the next meetup as well. Okay, let's start with our first speaker, Leroy Lim. Can you please join in? Thank you so much.
Cool. All right, let's get it started. Okay. Okay, today I'll be walking through EKS on what he has to offer for the simplified EKS permission management. I'm Leroy, and I'm a technical account manager in AWS. Mainly, I help to review EKS environments through well-architected frameworks and see in terms of operational excellence, cost optimization, security, that kind of aspect. And today we'll be sharing more towards on how, if you're using EKS, how do you manage the permissions, be it in the cluster, into the cluster and out of the cluster. And this will fall under either operational excellence or security. Okay. So in terms of agenda, I will briefly go through how traditionally, as an EKS administrator, how do you manage the permissions? And then I will share more about the new features we have from AWS in terms of IAM access entries, what is it about, and also EKS pod identities. Then I will do a quick short demo along with FAQ of that. All right. Okay. So when we talk about EKS permission management, I need to talk about first when we first from AWS, when we first used the open source Kubernetes, we had security as one of our core service offering for Kubernetes. And to do so, we actually integrated our AWS IAM into Kubernetes. So for EKS, if you're using EKS already, you will know that everything that you use to manage EKS, from accessing, deploying resources to how the workloads inside access and manage any of the other AWS resources from your EKS cluster is all via IAM. And this is achieved via what we call two portions. The left side will be into the cluster. That means from an administrator point of view, how you view resources, how you edit the resources, how you deploy resources. And this is done traditionally using a Kubernetes config map. And we use AWS auth to map all these permissions. From the other end, from your pods and your worker nodes, how do you access other AWS resources like your databases, S3 bucket, all this storage, or even other serverless resources? These are also managed via IAM roles. So they have, by default, something similar to your EC2, your worker nodes, the IAM, or if you're using security best practices in the past, it'll be what we call IAM role for service account, RSA, all right? So these two are how, in the past, how we use EKS to manage all these IAM resources. Starting from last year end, around December, I think if you watch the re:Invent, we actually have two new features to, in a sense, enhance what we currently have for your IAM permissions. So for into the cluster kind of portion, we have IAM access entries. I will talk more about all these two features in detail later. But basically, what it does, you can think of it as a form of a replacement for your config map to simplify the management. Then from the other end, from RSA, we naturally progress. We have learned from the limitations that you have from RSA to moving towards EKS POD Identity. Okay. So it's okay to not understand what this tool does right now, because right now it's just names. So I'm going to go in more in detail on what it actually does. Okay. So I will start first with into the cluster, the left portion just now. So which is what we call the cluster access management. Okay. For the architecture of traditionally how we used to do it using config map AWS auth is actually you have a Kubernetes config file in the cluster itself. So from an administrator, how they determine whether this user have the permission to access the cluster, you actually have this mapping inside your Kubernetes, one object called config map AWS auth that maps whether you are an administrator, you're a user, you have viewer rights, you have edit rights, etc. And when you use kubectl to access the cluster itself, you actually track your IAM role. You authenticate this IAM role, whether you are actually the IAM role, your token, you're authenticated, and then check against this config map to see whether what kind of permission you have for this cluster. Okay, this works fine by itself. Like there's nothing wrong because we've been using, but there is kind of an operational challenge here because one, the only way to know whether you have the permissions is you must go into the through kubectl to check whether this IAM role have the permission. And that can be quite troublesome once you have many users or many clusters. So what we do is actually, we try to decouple it. So what we do is we elevate from this config map, instead of having it stored inside each of the EKS clusters, we move it to the AWS service plane. So it becomes an API level kind of service. And we call it IAM access entries. So access entries in the sense that this mapping is now on AWS service plane. You can use any of your APS API to run, like that's how you will check for your IAM role right now, whether what role you're authenticated using your CLI, etc., or API. You can also do the same now using access entries. And then you will know whether your particular role is allowed what kind of permissions in which cluster. Okay, so this allows you for the first point you can use IAC or CLI or any commands to manage the cluster now. From the cluster point, you can just add a parameter to add, for example, I give this role now the permission to manage this cluster or view the cluster. Okay, and it also helps you in terms of scalability, because now you do not need to do it for every cluster. From just one CLI command, you can check for all your clusters that you currently manage, be it on this account or different accounts. So it's a lot simpler using CLI and API. And finally, the last one is one of the more useful kind of, I would say, what commonly asked for by a lot of users is traditionally when you run, you create a EKS cluster, by default, the cluster creator is the IAM that was used during that time to create the cluster. And this is what we call a super admin. And a lot of times, sometimes for whatever reason, we were operational lapse or whatever, that IAM user role might be deleted. Or maybe you lost access to the IAM role. And that becomes a very challenging aspect, especially if you get locked out of the config map, you have no way to access the cluster, and then you have no access to the original super admin, or you don't even know who's the super admin. And that's a very, very big problem in the past, because now you're locked out of this cluster, you can't manage it. Now with SS entries, we decoupled it as well. One, by default, when you create a cluster using SS entries, you will know who is the cluster creator. The role is there. Second, you can also remove it and reassign to another user on another role. So you can quickly, there's some transition, etc. You want to move the management to another role, or for whatever reason, you want to change the role that is managing the cluster. This can be now done very easily now. Okay. So from an architecture point of view, okay, there's actually two aspects. The top half is the one I'll be focusing on. For the SS entries, you can think from the left side, the principal or the IAM user or IAM role. You first authenticate to the normal, your IAM role. So you get the SDS token, etc. You assume the role. Once you're successfully authenticated, when you want to use another kubectl to access your cluster, etc., you will check against the SS entries mapping. Okay, so this you'll replace in the past where it goes to your Kubernetes cluster config map. So this SS entry replace that role. Then you'll go to your EKS authorizer, and subsequently all about this. You'll function exactly the same. So you'll check your mapping, you have the permission, then you give you the execute the respective Kubernetes APIs. Okay, so the bottom half is if you're using a hybrid approach, this is how your usual config map will work in the past. There is a IAM authenticator in the Kubernetes control plane. So that you'll then check whether you're authenticated on the IAM role, and then you'll check against your config map. Then go back to your EKS, your K8S authorizers and run your Kubernetes API. So that is the old approach. So the top is the new approach. So one question probably you will have will be, so how do I start using this? So the good thing is there is no need to create a new cluster out of it. You can just modify, later I can show you through a demo, whether you want to do through API or console, you can just change the authentication mode. So if you want to create a new cluster, you can also use whether EKS-CTL, you want to use AWS CLI, API, etc. There's an additional parameter at the last line, which is access config authentication mode. So there's three possible values. Config map is the old one. So that's how you've been using in the past for managing EKS cluster, the config map. The hybrid approach means you activate both. You can use both config map and the API. Both way works. You'll check both mappings, and whichever gives you the permission, you'll let you access. And the final one will be purely API. That's so if you want to be future-proof of a cluster, so that's the way to go, then you just use pure API. Okay. So one thing to note is with the launch of SS entries, config map is officially deprecated. So in a future version, that version has not been fixed yet. There will be a version in EKS where they will no longer support config map as an authentication mode. So if you're using config map right now, you can start to think how to do a transition, maybe use the hybrid approach of the both API and config map, and slowly transit your users towards APIs. Once you enable APIs, it cannot be disabled. And also, once you disable the config map, you cannot re-enable config map. So that is a big change. So do bear in mind when you're doing your migration towards API. Okay. So for authentication, Some things to key points I want to note here, you'll be more of you can custom your username when you're using your API to log in. So it's like your assumed role. You usually have a username at the end of your role. So usually by default, it could be a session name or could be your name of the employee, etc. You can configure it as such in your access entry as well, be it the access key ID or the account ID or session name, whichever will be simpler for your auditing purposes in your CloudTrail. We support cross account, so you can enable a different user at a different account to access your cluster as well. One thing to note will be for the how it maps the ID is actually not using your IAM ARN. It's actually using your principal ID, which is a unique ID when you create your IAM. What this means is that if for some reason you deleted the original IAM role, let's say the role is called role A, and you map this role A to be, let's say, cluster admin. But then you deleted the role A and you recreate the same exact role A name. On ARN, it's the same exact ARN, there's no change. But somehow when you assume role A, you no longer can access the cluster. It's because access entry uses principal ID to track, not the ARN itself. So that's one thing to note. But it's easily fixed. All you need to do is to just recreate the association. You just delete the old association and then reassociate role A to be, example, the admin or the viewer. Then the problem is fixed. Okay. And how access entry works in general is similar to how IAM works. So the update is also quite fast. Usually takes a few seconds, at most maybe a minute. Okay. In terms of authorization, we support namespace kind of scope or we support cluster scope, just like how you do it for your open source Kubernetes. So you can do Kubernetes group, you can assign whether just this user have access to this namespace, can only view resources in this namespace, or you want to give a cluster admin roles, etc. So all these, right now, access entries have what we call preset access policies, which later in the demo, I'll give you a rough preview of how it looks like. You can actually see also in AWS documentation or the Kubernetes open source as well. We have a preset list of permissions given that you can assign to user or group of users. For worker nodes and other Kubernetes objects, you can also use access entry to give permissions. So that's one thing to note, right? Because in the past, we use config map to allow nodes to have the permission to, example, register in some of the cluster. So with config map going away, there must be a replacement for it. And you can assign using this, what we call access entry types, whether we EC2 Linux or EC2 Windows, if you're depending on the OS, or you're using Fargate, there's another one called Fargate Linux. So you can just associate, just need to make sure that the IAM role have the IAM pass role permission so that they can assume the role to get the permissions to access the Kubernetes cluster. Okay. So that will be for accessing into the cluster. So for accessing out of the cluster, I will talk more about RSA and EKS POD identities. So in the past, if you're running pods that your workloads you want to access, let's say for example, you access S3 buckets. The permission by itself, the EC2 machines, the worker nodes by itself do not have the permission to access the S3 buckets. So there are a few ways to do it. The simplest way is simply add the S3 permission, let's say the read permission or get object or put object permission into the EC2 IAM role itself, which is the worker node. But that comes a risk when you're running many workloads in your worker nodes, because let's say port A and port B, they are running different workloads and you do not want port B to access port A data. If you're using just EC2 IAM role, it's too permissive. So usually for best practices, we will use RSA. And what it does is each of these port will now have your own roles. So in the bottom, you can see port A have a role A, and role A can access role A's data, but cannot access maybe roles B kind of S3 bucket data. And usually from a single cluster point of view, that works fine because now you segregate all the permissions. like everything is good. There's no way for, let's say, a different workload to access some sensitive data, maybe a non-prod access a prod data example. But from our experience, for bigger customers, and once you start using many different clusters, that comes to a challenging point. Because how RSA works is they work by using trust policy in the IAM. For it to have the permission, it relies on two things. One, the cluster itself, OIDC provider, you can think of it like an identity kind of a link. It must be registered, and you must add this, you must trust this IOIDC in the IAM trust policy so that you can assume the role properly. But in AWS, in the trust policy, there's actually a character limit. So usually you can add about around 5 to 8 clusters. And once you want to use this role for, let's say, 10 clusters, you will reach a problem. You cannot use the same role for 10 clusters. What people do in the past is they create a second identical role for the maybe 6 cluster onwards. Then there'll be another operational challenge. If I want to do some permission changes, I now need to keep track of all these IAM roles for the same workload, which doesn't really make sense anymore. So we decoupled this as well by moving the trust policy from the OIDC level in each of the cluster to the API level as well in the AWS service plane. So instead of trusting each of the cluster's OIDC provider, now you just trust one service principal called EKS pods. And by doing so, you get away with the limitation of your trust policy in the IAM role, thereby going away the limit of previously 5 to 8 clusters. Now you can use this same role across many different clusters. Again, the advantage, same as the access entries, you can now use API to track where this role is being mapped for each cluster through API as well. So you can easily track, okay, this role now is linked to this service account in which cluster. So you can easily track. Because in the past, you have to manually go to the cluster, look at the service account, see whether they're annotated, then you can find out, oh, this is associated with this role. So that takes a bit more time. Now with an API, you can really find, okay, this role is associated with this service account in which namespace. And then one final feature for EKS POD Identity as well, which later I'll go in more detail, will be what we call session tag support. So it is a bit similar in how you assume role. Also, again, when you assume role, there's actually certain tags being added to it. And these tags add to them certain metadata that a user will have when they're using the EKS cluster. Some example, you include the EKS cluster it comes from, the namespace it's using. You can use these to do more fine-grained permission control, which I'll later show in the demo as well. From architecture, maybe this is a bit small, so I will say more in a high-level kind of view. So from the top, previously, as I mentioned, you need OIDC provider for RSA. So what that means is you cannot create your role trust relationship until the EKS cluster is created and you register the OIDC provider. Now with EKS POD identities, you do not need to wait until the EKS provider, EKS cluster is provisioned, because the service principle is always the same, is EKS pods. So you can actually get ready your trust relationship. You can prepare your IAM role, all the permissions, even before the cluster is being created or is being created. That saves you some time as well. And once it's created already, the IAM role and your cluster is ready, you just use the API to associate the service account that you wish to use, the namespace, to this particular role. Once that is done, next step, you need to install the add-on in your EKS cluster. So EKS POD Identity relies on an add-on, which essentially deploys a daemon set in each of your worker nodes. And how it authenticate is if the pod has a service account tagged to it, it now contact this agent and authenticate using the service account. The agent then checks whether this service account is associated with any IAM role and gives you the token for it. And then your workload can proceed as per normal. All right. So there's some considerations, or maybe when you want to think about using EKS POD Identity, you'll be that for now, each of the service account can be associated to one IAM role in that cluster. Okay. Then for the role, it must be, this role that you're associating must be the same AWS account as the cluster. of course, you can allow other across account to assume that role. So there's still some cross account support. And the third point is, which I mentioned already, you must install the add-on in your EKS cluster. Some networking requirements will be users port 80 and 2703, some things to note. If you're managing your EKS cluster, you need to know what you need to allow, what kind of ports to open. And this is the IP if you want to do your auditing. Another key point, which for EKS port identity is, apart from RSA, which didn't have this requirement, EKS port identity has a requirement or dependency on your SDK version of your application. The reason being is it uses API to authenticate. As such, older SDK version did not have this API support. And while we support all the major programming languages, when you're using EKS port identity, do remember to update your SDK version respectively for your EKS version for your application. Okay, so this is a quick summary on the changes, which I already mentioned most of them. So in terms of scalability, EKS port identity definitely will be better. In terms of you setting up in terms of the service trust relationship with the service principal, port identity will be better. One thing you may note will be in terms of where it's being supported. So EKS port identity is API driven and is more integrated with EKS. So as of now, only EKS is supported. If you're using self-managed or self-hosted Kubernetes cluster on your EC2, if you're using ROSA, you're using EKS anywhere, as of now, you can only use RSA. So port identity is not available for those yet. Okay, so RSA will still be around. It's not being deprecated. So you still can use both at the same time. Actually, both can be run at the same time. Just that it can get confusing for as a operator managing it. So I recommend using one for now. Okay, so you see which one suits your end, especially if you're using multi-cluster, many different clusters using same role, then EKS port identity will suit your need more. Okay. So I will now move to just now what I mentioned in terms of session tag. So how does session tag helps in fine-grained permissions? Just now I mentioned one of the tag that is supported will be the EKS name. So suppose you have a situation where you have two clusters. For this case, I call yellow and blue cluster. So yellow cluster could be a non-prod cluster and blue can be a prod cluster. And I do not want the yellow cluster to access prod data, even though I use the same IAM role with the same permissions. So this same permission, we can access secret manager, but I don't want this IAM role in container in yellow to access the secrets in blue. So I can put a IAM requirement that if the tag associated with this role is cluster name yellow, then he can only access the yellow secrets. And conversely, if it's cluster name blue, then you can only access the blue secrets. So if a container in yellow try to access the secrets in blue, you get access denied. Okay. Later in the demo, I'll give a quick, if I have time, I'll do a quick demo. So this is essentially how you write an IAM policy in your IAM role. Okay, some example in the terms of the conditions is very similar to how you write IAM conditions. Just make sure your tag, okay, what is the tag requirement that you need to have, example, yellow or blue or some namespace. Okay. High level, if you want to migrate to EKS port identity from RSA, you first install the add-on, then you start first find all the existing associations that you have previously on RSA, and then you map them accordingly to your roles. You update the trust relationship by adding the EKS ports .aws, Amazon AWS.com. Then after that, you can restart your deployments. Once everything is working as per normal, you can start to remove the annotation from the service accounts, and then you can delete the RSA statements from all the IAM rows. Okay. Okay, let me do a quick demo. Let me know if you can see the screen. Okay. Oh. Okay, before that, let me go to the console first. Okay, so this is probably a familiar page for most of you in terms of the cluster page. So for access entries, it's supported from 1.23 and above. For port identities, it's 1.24 and above. So my cluster right now is using it as a 1.30 as example. So both are supported. So where you can access both of them is actually under the access tab. Let me make a bit bigger as well. Okay. So under access tab, the first one you'll see is under access configuration. So this one you'll see under manage access. You can see just the three modes that I mentioned. So once you enable API, you cannot disable. Once you enable, let's say you want to disable config, you cannot disable. Okay. Okay. So where you add your access policies is actually here. Okay. So on the right side, you see the column there's an access policies. These are all the presets that's available from the documentation. You can add users, etc. All this as well. So what you can see here, what I'm doing now is, let's say I have this, I'm authenticated using this role called test case. So it has a view permission right now. So if I use get ports, etc., I will get to see them. But let's say I remove this access. Let's say I delete this guy now. Okay. Later when we go back to your test, then you will see that you will no longer have permission because it's being removed. So that's a lot easier to manage than config map. Later, give it a while to update. Okay. So you see now it's error, not authorized. So it's the same exact IAM role, which is the test case just now. I just remove it from the API level and it's updated in the Kubernetes level already. Okay. Okay. So next one will be in terms of port association. So this one, for the add-ons, I have already enabled it. So I already installed this in the add-ons from the IAM role. So I'll show you quickly where you add your. The main difference will be in terms of trace relationship, you add this pod.eks service principals. Then the permission I will give a few for this case. I will give that EC2 reading. I will give one for S3, which for my demo. I will give this one, this is a session tag. So this is for the cluster name session tag. Only when it is this cluster, they can access the S3 buckets. Okay. So I'll go back to my Kubernetes cluster. So what I do is actually set up a pod. Let me change, give me a moment. So I'll change to a IAM role with cluster admin permission so I can access the pod. So I have a pod running with SDK that supports EKS POD identities. Okay, so I will access inside. And what I'll do is I'll show you the current permissions it's using, the role. So what this does is actually just pull out the role is being assumed. So you can see that it's assuming the role of the pod identity that just now using the pod identity, the associated mapping of the IAM, which is pod identity role. Okay. So if I do what I do now, if I use access the S3 bucket, you should be able to come up with the permissions to access the bucket. So you create a S3 pre-sign, and if I run it, you will download the object straight away. Okay. So now what if I do is, if instead of this, I just remove the permissions. Let's say I just change this. Let's say the cluster name to some other cluster name, then it will fail. In a sense, you'll get access denied because it doesn't match. So let's say I just put demo 1 instead. Okay. So again, you give it a while. So after it updates, once the IAM permissions are active and live, when you try to generate the S3 permission, you generate a URL, but once you try to access the URL, you'll get access denied. So let's try now. Okay. Okay. I think this one done, right? Yep. So this is the last one, that's nice. So you see now the permission is access denied because now the IAM policy no longer allows for it. Okay. So that's the end of my quick demo. Okay. Thank you, everyone.
Oh, nice. Perfect. Hey, thanks everybody. Hello, we're good. Thank you very much. Okay, well, thanks for coming everybody. I know coming today was very difficult. It's a Monday. I still thank all of you for, oh, it's a Tuesday. Oh, felt like a Monday for me. Okay. Well, still a very difficult day to come. Thank you very much for coming. Just a show of hands, how many of you have seen me around in this meetup before? Okay, few familiar faces around that. So this probably is my fourth time around here, and today I'll be doing something a little bit different. The title's a little bit of a Frankenstein monstrosity. There should be a on, and you didn't see that earlier on, right? So I've added it over here. Really, I think today I'm just going to share a little bit more in terms of my experience with people who I talked about, what are key considerations after they deploy the AIs on Kubernetes or even on some of their physical server farms around there, right? I saw a few hands, of course, so I'll do a quick introduction myself again. So my name is Mun Kiat, MK, most people call me MK. So I'm from Thai. I'm a technical architect. Half the time I'm a technical architect, half the time I'm a meme maker within the team. So in today's presentation, I will be incorporating some use of memes for making it a bit lighthearted so that you kind of enjoy this evening's talk. So hopefully it will give you some energy. So quick introduction. So I'm from Thai. We are actually an API management solutions company within Singapore. We are based in Singapore. My colleagues, fortunately, right, unlike the last times, today are here with me, right? Normally one or two will join, but today I have the full team. So if you see any of them in the room and you identify them, say hi. They might be able to give you some tips for that quiz later. So I've given them the answers, basically, right? Hunt them down, find them, and get the answers from them so that you win something from us. Okay, so topic proper, right? So firstly, I'm talking about AI. So how many of you over here use some form of AI tools? What do you guys generally use? GPT? Do you pay for them? Olama. I actually have a demo on Olama later, and you can see that. Okay, so and that's the whole considerations around that. Okay, so I personally pay about 40 US per month for AI tools. I find it very, very useful. A subscription to, I think I'm a flip-flopper, right? So I change between cloud, if you guys know Cloud AI and ChatGPT every other month, just depending on who comes up on top of the AI leaderboard rankings every month, right? So I pay $20 on that, and then I pay $20 for another AI coding tool called Cursor over there. I find it very useful around that. And I think today's sharing, hopefully you guys kind of get a sense of how people are putting AI into production, the key considerations around that, because it's not just like this guy over here, right? Downloading Ollama, going there, Ollama run Mistral, Ollama run Llama 3.1, 3.2, and that's it, right? There's a lot of considerations around that. But for those of you who successfully did manage to deploy, your first semblance of AI either locally or around your companies, congratulations. That's my message to you first. That's me, right? Showing my boss that I've deployed AI successfully, but actually I just went to the website, double-click ollama.exe. So the one thing about that, right, with rolling that out in your team is first you start using it, then you share it with your friends, your colleagues, then more and more people use, and then suddenly you get the whole world doing that. At Dyke itself, we started AI adoption kind of early. When ChatGPT came out, we actually have a Slack bot we call, his first name was Lurch, then Lodge, now he's called Wadsworth. But then the whole company was using that tool around there, right? We face quite the number of key considerations putting out into production, things like consumption, cost, all of that, especially once every powered on, right? There was a very, very funny scene on our Slack channel where one of our QA tested it and asked two chatbots if they knew each other, right? What happened after that was two chatbots talking to each other, spamming Slack for 500 over messages automatically around that. And it cannot be stopped. That's the worst thing, right? So the downside of rolling that out and proudly saying that you did is that a lot of people are going to start using it. They're going to test it. They're going to want to try to break it, right? And eventually what happens is the user experience degrades, right? It's going to be slow. And Champ, you roll out Ollama, right? It's slow, is it? Yeah, right. Still very slow, and it's not very high performance, to be honest, right? You get all, and if you share it everybody's going to use it. They want to see what you have done. And so these are the factors, right? If you ever want to deep dive into rolling out AI in your environment, right? What is this? Precision, the number of users, model size, architecture, all that kind of stuff. All of this from software, firmware, hardware, down to even temperature control, cooling, all of that. And if you are one of those people who are concerned about cost, you probably might even want to think of how much you're paying for per kilowatt of hour for rolling out that, right? So take note of this page. This is quite important. Big clue, quiz later, right? Factors that affect UX of that, right? As more and more people use, right? Even they do complex stuff. Like for me, when I use coding, even a 12K context windows generally is not enough for me. I think 20 and I think Cloud gives me a 200K context window. Good for me. So the thing is, you get very, very, very slow response. People come complain, like the slop itself, it's really not pleasant, right? And so what's deemed to be very supposed to be life-changing, it's not really life-changing, it's very slow. And I'll show you an Ollama one on my local environment, and you'll realize that kind of like a slop, right? Worse, blue screen of that. Of course, it doesn't run on Windows, right? But slow's probably the least of your worries around that. I think more importantly is if you get crashes, things don't work, then it's kind of like a bigger problem around that. And so the first thing that comes to most of our minds, right, is boss, we need more money. You start to buy more, right? And it starts from top left all the way to bottom right. These aren't my projects, but I've taken this from Reddit, right? It really signifies how people start to think, buy more GPU. You can see this guy with 4 GPUs around there. Take notes, quiz question as well on here. Then people move to the cloud because it has a very OpEx-based model, thinking about pay per use, right? AWS on the top right over there, GPU instances, and then you have a cost for that, per hour kind of consumptive model. Good thing is going on cloud, you don't have to think about cooling, temperatures, humidity, all that kind of stuff with hardware. Then maybe move to something a little bit more purpose-built, right? Have you guys heard of Runpod? Runpod.io? Basically, distributed GPU services. The earlier version of that was someone was farming out compute to solve stuff. Now people are farming out GPU services so that you could do your AI stuff, right? So Runpod is quite a popular one. I know I haven't put the URL inside, but if you guys are interested in checking out, they are one of the, first steps where people look into running the AI workloads on. So Runpod, and then really on the extreme end, you get people finally deciding that the most cost-effective way is to put it at home, air conditioning on top, server rack, multiple servers, multiple GPUs running it all together, just for performance purposes. So the first line of thought, or at least the lowest hanging fruit people come to when in terms of solutioning, is scale out, buy more, right? But therein lies another way of approaching this from a solutions perspective. And that is after I've talked to some of, my customers, some of my prospects as well, is to basically limit that usage so that you can manage costs, manage UX, manage performance altogether around that. Because frankly speaking, most people, most of the time, use GPT for, hello, how are you? Please summarize this chunk of text. It's not, you don't need to give them the best services all the time, right? So the better way is to provide multiple services, route them into the right services, and limit their consumption around that. That way, the people who really rely on your services, the people who really rely on it for productivity, actually are able to do it without facing degraded experiences around that. And so when I talk to some of the people around it, and it didn't click to me in the first place, I'm an API management solutions provider. What do I have to do with AI, right? But then they came to me and say, right, actually everything's an API call, right? And the good thing about treating AI with API management solutioning is that you can think about things like restricting access a lot more because everything's an API call, right? You solve things like who can access it, identify yourself, can Ramat access my services by identifying himself as Ramat, or it's only MK who can do that. Which models can they access? It's an API call, we definitely can restrict access around that. How often? That's a function of time and for access limitation. How do we identify them? What do they need to present themselves with? And I think if you guys are consumers, or at least some of the more what I call hardcore consumers, you don't use the web UI, you actually use the API key, right? Integrate that with your IDEs, maybe some of your own tools that you have, right? And maybe even from a more complex use case, right? It's not how often, it's also limiting the context window, right? So this last part, take note, it's going to come out in the quiz as well, right? Tokens, right? So how do you limit that? Because token is actually a parameter or one of those factors that affect performance around that. Smaller context window, sure, lighter, faster processing, but of course, less ideal results, less ideal UX around that. And as some of you may have seen me misclick quickly around that, is they come to me and ask, how can I start monetizing all of these AIs that I have? Because my users are not generating enough core usage, but I need to justify all of these costs. Can I farm some of this capacity out to someone else, right? How do I meter, invoice, bill for all of this? Very nicely put, all of these falls within the API management realm. Because everything's just an API call, right? So I'll show you a demo later. Unfortunately, it's a very slow one. I don't have a GPU on the MacBook around here, but you could see how we actually implement some level of access control, some level of identity management in terms of access. And from there, you could build out a lot more complicated models around that. Right? And this is how it looks like, right? In this diagram, clients basically would be mobile apps, web, even things like open web UI, right? Trying to access your different services around it. Most people have one. I have one, right? I don't run multiple around that. But in a more, I think, in a bigger org, right? You're not always going to serve them the best. In a flight, right? You have first class, you have premium economy, and then you have economy class as well, right? So in my example over here, oops, there are two service B, but you could see I have best, most balanced, and cheapest over here. So depending on what kind of API key that you are being given, you can then tell them, hello, you have access to the cheapest and fastest model. They wouldn't say the poorest performing because that's a marketing thing, right? But they'll say cheapest but fastest. Best service, best for the LLMs and all of that. And so an API gateway does simple stuff like that. So Tyke does this for you. We do authentication, identifying who you are. We do quotas check. So it's kind of very, very simple. If you are very familiar, right? How many users of the AI, how many tokens, how often can you do that? We can check the quota for you. We can then limit them, throttle them, depending on their quota for the month, right? And of course, I think the most powerful thing would be routing as well, right? So if you've exhausted your fast or premium model usage in a month, you go to the second tier, right? If you finish the second tier of service in a month as well, there you go to the cheapest tier, you go into economy class, right? So an API gateway does that very nicely and elegantly for you without you having to rebuild all of these components by hand. So it's very nice and elegant way to do so. And one of the best things I think with OpenAI and how they've drove open standards, right, is that Open API and OpenAI are different stuff. But OpenAI has actually delivered an OpenAI API standard, which allows for a lot of tools and a lot of LLM providers to provide a plug-and-play interface so that in cases like that, right, where an underperforming model, right, has maybe implemented some license restrictions, right, from free open source to restricted commercial usage, you can actually swap them out into a new service, right? From service A to service X. And because it's an OpenAI API compatible standard, you can swap them out with no impact to your users at all, right? They will consume the API just as if they're consuming API service A, and they do not notice the thing at all. So I think this is one of the very key and core developments in terms of AI and AI tools around that, such that API compatibility is critical in terms of being able to deliver best-in-class client experience, swapping them out, testing new models, and you don't have to build it from ground up again. And so some examples around that, people who have successfully done it, big players, Cloud, if you know, I use Cloud, ChatGPT on the right as well, many models. If you finish exhausting your quota for the month, just like I've used $20 for the month, they could charge me more for premium models, or they could route me to the slower models as well. And the other model in which you can draw inspiration from is what we call, not we call, but they call themselves Open Router. So basically, it's an API router to multiple API services based on price as well. So it adds a new dimension. I was talking about routing based on, quota, rates, performance, all that kind of stuff. But now there's someone who even managed to do an API or AI API router based on price. So at any one point of time, if you're looking for the cheapest, or you want to cap your consumption below a certain price, send your API through the Open Router, and Open Router actually does it to the different services for you. Once it gets the cheapest, it sends it to that LLM itself. So you don't have to worry about cost as well, because cost is a very pertinent thing when deploying AI. And then I was talking to a friend, this Ben, he was saying that some of their clients, when they were talking about rolling out AI, they stopped doing it altogether because the costs are very prohibitive, right? So it's a very important thing to think about, because eventually everything runs down to cost and justification and ROI around that. So if you're interested, I would leave a link. We do have a page where you can download the slides, and then that would have all the links to all of these projects around that. You could see how people have implemented API routing, so API level, authentication, authorization, all that kind of stuff, to get some level of efficiency within the operations around that. Because really speaking, it's really not just deploying your first AI application. It's about what do you do after that, because everybody's going to hammer it, everybody's going to use it, and it's going to crash some point or another. We've seen multiple crashes around that. So I'll go back to the takeaways later. I've talked about that. It doesn't end with just your successful deployment. Ultimately, key considerations or key outcomes would be user experience, cost control. You can do that. You can either scale out, buy more, or you can implement access control at the API level, because everything does an API. So examples over here, if someone hasn't paid, someone has exceeded, you can block them. And I think the lowest hanging fruit that you can think about is look at industry solutions, API gateways like Tyke. If the above are all too wordy, just remember API management is AI management. So what I'll do is, in my last 5 minutes, I'll show you guys a really quick demo. So I do have a local model, right? So So this is running locally on my MacBook. Doesn't come with a GPU. Very slow. Not very nice, huh? This is an example of really poor UX. But this is what you get, right? And I'm the only user for this. This is just my laptop, right? So think of it when you have 5, 10, 15, 20 people using it. You're going to have people complain that, could you actually make money off of a service like that? Would you pay for that? 10 seconds of response? No, right? You want to deliver best-in-class experience around that. And so what we could help do is we implement some level of discoverability and API management around that. So this is just a very simple portal that we have. Basically, you could create your AI service catalog around that. I've created some preloaded. Same backend really, but it's going to be secured by us. And this is just one, of course, as you have more and more models, you populate them. Very useful for discoverability. So if you have more and more people who do it self-service, I have an account that I've done it myself first, but then you could go in there, check it out, and say, okay, I want to go with the sandbox plan, right? Let's access the plan, go to my shopping cart. So you could probably think about how you want to start making money out of here, right? Test. Submit request, go to my apps, and there you go, right? You now are a proud owner of an API key that can access the AI model. Now, it will still be slow, right? Because the underlying machine is slow. But I think the key message is we can then do things that improve user experience, like caching, routing, and all of that. So with that, I'm gonna just preload this into my gateway, my local gateway around here. Same query, really, same model. Performance is not going to improve. I'll be very honest about that. But what we could do now, right, is then we could say, put in my, if I don't do anything, it says no access, right? You prevented someone with no access to use the service. And then now, plug in your API key. Oops. What is the problem? Embarrassing. I haven't prayed to the God of demos today. Okay, tell you what, I know my time's up. If you guys are interested to see me fix the demo, right, come look for me later. I'll be more than happy to help you guys. But I hope I've also dropped enough hints for the quiz later. Good luck, everybody. Hope you enjoyed that. And last but not least, Alok, just let me do one thing. Guys, if you want a copy of the slides, there you go. Right, it will include all the links to all the resources that I have. I think it just leads you to a simple form, fill it up, and then you can get a copy of those slides. So we have a local office, but we are all around the world. We started from London, UK, right? And then Singapore is the second office, whereas compared to most people, they will expand towards the west. So we started in London, and then second place would be in Singapore. So I'm here, I think we have long timers, 5 years here. Been here for a very, very long time, 7 years in fact. Yes. Thank you. Yes, so in the world of AIs, I think this is something that I think you guys should definitely consider, right? It definitely helps a little bit, if anything. I'll be fixing my stuff over there. Come find me if you are interested. Questions and answers as well, I'll be there. Thanks, everybody.
All right. Let me introduce you to myself. My name is Abhishek Srivastava. I'm working as a senior staff engineer in SPH Media. Now, my work revolves around platform and infrastructure, DevOps. In fact, Ritesh is part of my team here. And so there are these requirements where we have to provision accounts, where we have to create resources, and where we have to deploy things using CI/CD pipeline. So, yeah. You can see that things? Yeah. Good. Yeah, good. So, before even I joined SPH Media, I had no idea what this organization is. Like I didn't fathom the way they were using the technology. Because to me, a newspaper is a newspaper. But SPH Media has been a whole different story, a whole different journey for me. Some of the cutting edge technologies which I discovered here, I did not find it in my previous 14 years of experiences. So what is SPH Media? May I see the raise of hands of how many people know what SPH Media is and what are their products? Very few. Yes, the Straight Times, Business Times, and there are whole lot of channels and platforms through which SPH Media connects with you. So I'm not sure. Yeah. So these are all the publications, the magazines, the radio channels through which we. Am I audible? My mic is breaking, I guess. The voice is breaking. So sorry. So SPH Media is a prominent media organization of Singapore, which reaches out to the millions worldwide through different channels. It has a diverse set of portfolios uh, with news, lifestyle, and across various platforms. Now, with any media company across the world, there had been this transition which they have to adopt into the digital world because the world changed and now suddenly everyone had smartphones and print newspapers were the things of the uh, dinosaur age. So and I've been fortunate enough to be a part of that journey. Now, today in SPH Media, there's a whole technology unit where hundreds of projects being worked by thousands of engineers and day in and day night, and they're trying to bring this digital transformation to the SPH Media. Now, I'm trying to build my case here by talking all of this into CI/CD pipeline. And I want you to see the value of it, like where I'm heading to. All of these work which is happening, they go into a commit history. They go into some uh, 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 version control system, right? And that is GitHub for us. Now we use GitHub runners to build on those pipelines. When I say that, think about it, and I'm sure many of you must be knowing how those pipelines work. But for those who don't, when you commit something, there are whole lot of things which goes on, right from the linting checks to the security scanning, uh, to uh, to the conformance packages which your organization might require. And then you want to build something, maybe that is a package itself or a Docker image. And then that has to be pushed somewhere, and then eventually it has to be deployed. The whole function of this is called CI/CD, which is continuous integration and continuous deployment. Now, these steps, these executions would need some sort of compute to run on. And in the GitHub realm, those are called runners. I'm sure you would have worked with different CI/CD platforms, Jenkins, Bamboo. All of them would need this kind of resource to run these steps, to execute these functions in order to achieve the goal. At SPH Media, uh, we tested out a lot of these functionalities because CI/CD has been, and I'm sure it's with everyone, CI/CD is the backbone where all of these things, all your company converges and you deliver something meaningful out of it. So let me. So in today's topic, we're going to discuss about the self-hosted runners. When I told about the runners, the GitHub runners, they come into two flavors. One is the GitHub hosted runners itself, and then you have an option to self-host it. Although we are very modest, but we are very happy with the results what we achieved, and that's why we say that it's a mastery over the CI/CD with self-hosted runners, which we were able to get. And today I'm going to share that golden recipe with you. What is that? That would be Arc, controllers, and Karpenter. Now, another raise of hands, maybe I can get a sense of how many know Arc and Carpenter? Wow, okay. Not many. So what is exactly the Arc, and what is a Arc controller and Carpenter? Arc is developed by GitHub Actions, and which is a Kubernetes operator for managing the life cycle of a self-hosted runners. So when I say that, in the GitHub, when you create a repository, and most of you must be having organization and then the enterprise, above that, you create a runner group wherein you define and you assign those runner groups to your respective organization, to your repository. And within the workflow, you pass in these labels, like when you use workflow, GitHub Actions workflow. These are just simple YAML files wherein you write the steps, what you want to do, what all execution you want to do, the runners. So there are some labels, some key value pairs, which you can define. Runs on is one of those labels wherein you pass the label of the runner group, and the Arc, which is running on the Kubernetes system, it picks up that runner label and then deploys the self-hosted runners. Now, how it does and what is the workflow we're going to look into. And the Karpenter is a different project. It's a different open source project for the lifecycle management of the node. So your runner is a pod which needs a node to run. And the Karpenter ensures that you get that node available for the runners to run. Now, a question might come like, why did we choose even a self-hosted runner over a GitHub managed runners? So there are requirements where you have internal resources which are sitting into the networks which are not available over the public. That is one. Then the managed hosted runners in GitHub, they are running on a public platform, and it's a shared platform. And I'm sure many of you will not be comfortable with the shared platform having your secrets, having your authentications, out in the shared platform. So, and then the third thing is the cost itself. When you involve all this linting checks, all the security scannings, all the builds and deployments for each and every commit in all the different environments, the cost really escalates. So we saw a lot of value with the self-hosted runners, and that's how the decision was made, and we gravitated towards using it. Now, so I was trying to build a case and tell you that the Arc controllers and the Karpenter are the two beautiful combinations which we found, which solved our use case, giving us resiliency, scalability, security, and the cost optimization. So these are some of the features which we got with the self-hosted runners. So Arc helps us to segregate the workflow using runner groups. And we're going to look into the detailed workflow, how it works. But bear with me now if you don't understand some of the terms here. The Arc helps us to segregate the workflow using the runner groups, whereas Karpenter enable us to use ephemeral runners to provision for each workflow and optimize resource provisioning, because Karpenter efficiently provisions the right node types of our runners based on their resource requests. Now, somebody might say that there are Kubernetes autoscalers. Why don't we use it? Now, you're going to see the value when I show you the config for the Karpenter. Because within the Karpenter, you can define all these. So Kubernetes has these well-defined labels through which Karpenter can choose the optimal node for your run task. Let's say you want to run something, you can choose the spot instances, you can choose the range of the instance type, you can choose based on the memory and CPU. So all these parameters you can configure for the Karpenter, and based on that, the most optimal node can be chosen. However, autoscaler does not provide all these. I mean, it is not actually built for that use case. So you would see in the config when we go to that page. Now, how exactly it works? So there is this GitHub action workflow trigger, which I talked about. So within your repository, inside .github folder, inside the workflow folder, so it's a .github/workflows. Inside that, through the YAML file, you define your GitHub actions. And those actions could be anything from the linting checks to the builds to the deployment. Now, so in that workflow, you need to define a label, and we will see how that label is defined, but there is a key value metric which you pass in to choose the runner group. Now, when that request is received by the Arc controller, which is running in the EKS cluster, which does a long polling on the GitHub repository in which you are running the workflow. So the GitHub controller fetches that request and create these ephemeral runners and request for the node for these runner pods to be hosted on. And there the Karpenter comes into picture. When this request comes for the node for the pod to run, the Karpenter config, it kicks into action. It provisions the very optimal node for you to host that pod, which is very ephemeral in nature as well. Like your pod runs that code and the node and the pod, they both dies, leaving no trace, keeping you totally secure. Yeah, and then the Kubernetes runner execution happens, and sorry, the arrow left. It was supposed to stay. And then the Karpenter terminates the node. So this is the workflow in a nutshell. Now we're going to look a little more into how this Arc is behaving. So as I said, Arc is a operator which has host of controllers within it. Now let's go sequentially to see what exactly is happening. If you see, there is this Arc controller manager, which has these different resources within it, which is like the auto scaling, listener controller, auto scaling runner set controller. So in the very first step, which you see, right, what is happening is the controller is installed using the Helm chart. So after this, I will share the link to you and you can find all the details how to install this. But what happens, like when you install this through the Helm chart, a controller manager pod is deployed in the specified namespace. And a new auto scaling runner set resource is deployed, which so now what happens in the second section is the auto scaling runner set controller. It calls an API, and uh, you need to pass in those authentications already. So there is a GitHub app you can create, or you can create a PAT token through which the controller and the GitHub, they communicate with each other, like they authenticate to each other. So now this controller, it checks one more thing on the GitHub side, you have to manually configure the runner sets, the runner group, which is which defines, like, you create a runner group within the GitHub itself, and then you assign this runner group to a respective repository, to a respective organization. So that depends, and it's one of the segregation which you can make on the GitHub side. I don't have the slide for this, and I cannot share my organizational GitHub repository, but take it for my word that you can create a GitHub runner group within the organization, within the enterprise, or within the repository itself. Now, what exactly happens is, like, the GitHub controller set, the GitHub runner set controller, it it tries to fetch the runner group ID and creates this runner scalar set listener resource. This listener resource then makes a long poll, HTTP long poll connection, and keep listening for on that runner group, and keep listening for uh, uh, any notification from the GitHub. Now, what happens in the fourth step, when a workflow run is triggered, like when you commit something and you define in the workflow that when you push the workflow should, so there are different ways in which you can trigger the workflow. Either it can happen on a push to a respective branches, or it can happen when you create a tag or a release, or you can manually trigger it. So when that trigger happens, then the GitHub Action Service dispatches individual job runs to the runners. And this listener is listening for it, right? Which is having a long poll. Now, when this job is available for this listener, what it does in the step fifth, it acknowledges the message. And in the step sixth, the runner set listener uses a service account and role to that account to make an HTTPS call and creates a ephemeral runner set resource. In the step 7, which you see, right, ephemeral runner set, it attempts to create a new runner. Now, what is that runner? It's just a pod with a couple of containers within it. One container is for the job to run, and there the carpenter kicks into action. So this pod is now waiting for a node to be taken over, and then we'll see in the carpenter config that how you define that for the node to come up, and that pod is then deployed on that node and it runs. Yeah. So we'll not go into so later on when that happens in the eighth and ninth step, the runner is created, and in the ninth step, the GitHub Action Service acknowledges the runner registration, dispatches the job run details, and once that execution happens in the 11th step, the ephemeral runner controller checks with the GitHub Action Service to see if the runner can be deleted, and if it can be, the ephemeral runner set deletes the runner. So this has been a little bit deep dive into the R. Let's see how the Karpenter works. Now you see these pending pods on like the sequence 1, which you see. These are the pending pods which the Arc runner set requests for. And the Karpenter, the blue area, the Karpenter, is a controller which listens and deploys the node. Based on what? Based on the node pool and node class, which you see there are two pink small folders down, node class and node pool, where you define in the constraints. And that would be what? That could be a taint and the tolerance. So in the pod, in the Arc controller, you define the tolerance, like some labels. If you don't understand what pod, how this tolerance and taint works, it is nothing but it is some sort of a label which is being checked by. So it has to match from the pod and on the node. Like if you pass in some labels, if that matches with the node, then the pod get deployed and on that node or otherwise as well. So those are the configs which you push in into the node pool. And node class defines what kind of, so in the realm of AWS, the node class are the EC2 instances. So let us look into one of the Karpenter configuration, how it looks like. On the left-hand side where it says like node pool, this is the configuration which you pass in, wherein you tell that what is the key, like what is the instance family in which that node should come in. And there are all these well-defined labels in Karpenter, in EKS, like the instance family, the instance class, the memory, the CPU, the architecture, all are, and there's a list of it in the documentation already you can find. These kind of settings you can put into the node pool settings. So in this case, it is saying that I want an instance family in P3. And if you see, there's a taints, nvidia.com/GPU true no schedule. So this is a taint which goes into that node. And on the pod side, on the right side, you would see there is a toleration for that pod. And it is checking for that taint. So once this taint is, once this toleration is there and the node matches that toleration, it would deploy it. And the Karpenter would then find this node from the node pool, depending on the configuration, what kind of node it has to deploy, and it will deploy that pod onto it. Now, let me just quickly show you like how we do it in SPH. And maybe that could be a small demo. Okay, let me know when you are able to see the screen. It's there, right? Okay. Yeah. So this is one of the is- Cannot see that? Do you see now? Okay, I see. Stay now? Display वाला? Okay, okay. Yeah, just concluding this. So we are using Terraform for everything, most of the things within our infrastructure. And that's how even we deploy our Kubernetes deployments. This is a quick example of how we create the node pools. And these values are then passed on to the YAML into the Helm values. So, I mean, if you could see, these are the taints which we are passing to that node. Okay. Is it good? So not everything is important, but you could see that we are passing some taints into that node. These are the requirement of that node which should come up. Like the instance category should be M, the instance generation should be either 5 or 6. It should be an on-demand instance. Like for your other environment, state and development, you can put a spot as well. And then the architecture could be AMD 64. So these are well-defined labels in Kubernetes, and you can find the list in the documentation. So this is how you define a node pool. Then there is a disruption, like once the job is done, how would the carpenter deal with the node, how to disrupt it? So there are certain values which you can pass on, which is when underutilized, when empty, and there are certain other type of configs which you can pass. Or the job has been running for 168 hours or something, you can pass the time as well. Like if this node is up for this many number of hours, then I just want it to be killed. So these are some of the Carpenter configs. Now quickly, I want to also show you the Arc config. This is how we create the runner set. And bear in mind, this is after you have deployed the Carpenter, after you've deployed the Arc runners, Arc operators in the Kubernetes. These are the settings which you pass in to create the runner set, to create the node pools within the ecosystem of Carpenter and Arc. So here we are passing this, we are defining the runner group, which we created on the GitHub manually. And then the runner set name, which is which we yeah, so this runner set name is then used by the workflows to pass in the job. So on the workflow, when you define runs on, this is the runner set name which you pass in. And these are the containers which runs the job. So there's already well documented way in which you would run the containers within it. So these are the containers which make that GitHub job happen. Now quickly, I just want to show you the workflow, how it looks like. Maybe I have it over here, so, yeah. Are you able to see this? Okay. So this is how the workflow file looks like, a simple YAML file, which you put in into that path, the GitHub/workflow/YAML file. And there you define the runs on key, and you define the value which you have created the runner set with. Now the whole picture is when you trigger the workflow, either through a commit or through a manual run, this then goes into, there's a long poll which is happening. The Arc runner controller is listening for that into that runner group. It picks up the job. Now, when it tries to create the pod, it engages the carpenter. It gives the carpenter, those taints are then, the tolerations of that pod are passed on. The carpenter controller looks into those tolerations. It creates the node based on the node pool with that taints, and then your runner jobs get hosted there. It runs, it does what it has to do. It runs all those compute, what you have written in the workflow. In this case, it is hello world. And then once it is done, the carpenter disruption config, it disrupts, it deletes the node, it clears, the finalizer steps runs, and you get a clean slate again to work with. So yeah, with that, I want to end my presentation. Just, yeah, these are some of the helpful links, and this presentation will be available on the site, right, afterwards?
Yeah, we'll share later.
Okay. And please scan this. Let's be friends. Thank you so much.
Okay. So KubeNots is a program which is a person who completes all the 5 certificates of Kubernetes, that is CKA, which is administrator, CKAD for developer, and security specialist, CKS, and then KCNA and KC security associate. These are the 5 certificates which we can master in Kubernetes. So you need to complete all these 5 certificates to be a KubeNot. Once you are KubeNot, you get this blue jacket and many other benefits attached with it. How many people are KubeNots? There are 15 in Singapore. Globally, we have 700 around, and in APAC, we have 200, India, 10% of it. So in Singapore, we just have 15 KubeNots. How many of you are interested to be a KubeNot and add your number here in Singapore? Okay. So if you are interested to give the exam on the certification, you first need to prepare. And to prepare, you have option. You can learn on Code Cloud all these technologies, and all these courses are present on Code Cloud. You can use these offerings. You will get a pro offering 47% and a business offering on 40%. So you just need to use this coupon code. And once you're ready and you have already ready to give the exam, you have some offerings for the certification cost as well. That is almost 40% you need to use this particular code. Just have a snap if you want, and if you're planning to learn or give the certification. Okay, let's move it. Just like the KubeNots program, we have the AWS Not program. There are 13 certificates in AWS. If a person completes all these 13 certificates, a person becomes a AWS Not. You get a golden jacket. So you need to choose or be a master of both. Yes, definitely. you can be a master of both, being a kubenaut and AWS naut. Okay, how to connect to us? If you want to be a speaker in this meetup, you can scan the speaker code. If you want to be a volunteer with us and host these events with us, you can scan the volunteer code. And if you want to be a sponsor, happy, okay, you can scan the sponsor code. Okay. Please follow us on LinkedIn, Twitter, and Telegram. It's an active community. We can keep on posting new updates related to the technology and anything that is interested around the technologies. So do connect. Your feedback is definitely important. Here's QR code if you want to give some feedback. What else we can do in this particular meetups? What you are looking at? Your suggestions are valuable. Please scan this QR code and please provide your valuable feedback. Okay. Okay. Interesting time. Please take out your mobile phones. Let's go with some kind of quiz. I hope you have attended all the three speakers and you were being very careful listening to them. Let's start the quiz. Can you please scan this QR code? The quiz code is 951570. If anyone has any trouble signing in, please let me know. Are we ready to start?
Do I need to sign in?
Yes. Yes. You can give your name or a dummy name. We see 5 participants, 6, 7. Okay, let's start with the first question. We have 18 participants. Just look at the screen. I won't iterate the question. It will lose your time. So the first person who will give the answer, that time counts. Okay, let's start with the first question. Okay, so the right option is optimizes node provisioning for runner base. Let's go to the next question, given the time is short. Arc region. Okay, 52% of you were right. Nice. We have the updated leaderboard. Next question. Okay, 76% of you were right. That's good. You're paying attention. Next question. Let's do it quick. Type of nodes to launch. Okay, 14%. Okay, and better luck for the next question. Let's move ahead. Okay, 86%. That's nice. Let's go to the next one. Yes, that's Philippines, and that's right. Okay, we have the leaderboard. We have the top 3. Okay, the top 3 will get 6 months of Code Cloud subscriptions. Okay, yeah, Cap. Can I have the top 3? Shinmay, Abhishek, and Sarel. Are you gonna? Can I have the top 3 here, please? In front of you. Yes. Hey.
Technically,
Okay, we need the 4th guy. We need the 4th one. Who is Dave Dinesh? Thank you. Thank you so much, guys. We have the first three officially here. Let's take a photo. Take it here in front of you. Okay, guys, thank you so much for joining this evening on this meetup of 33rd meetup. Let's join together in front of the stage to have a group photo. May I please request you to join in front? Thank you so much. Come, please join the stage.